Thank you. Can you all hear me okay? Yeah. So thanks very much for coming, and I'm going to kick off the day with a brief overview on pine weevils, their biology, and the project we had that Nuala mentioned, so Pine Weevil IPM, towards integrated pest management of the pine weevil in Ireland. So first of all, what are pine weevils? So pine weevil, or Holobius aviatus, is a serious pest of reforestation in Ireland. You can see one there on a little seedling. So adults damage young trees by feeding on the bark. They can actually kill up to 90% of seedlings with an average of 50% by feeding on unprotected seedlings. So that's seedlings that don't receive an insecticide. So the conifer stumps that remain on clear fell sites are ideal breeding ground for pine weevils, and one conifer stump can actually contain up to 300 larvae. So basically, pine weevils are a pest wherever conifer plantations are clear felled and sites replanted. You can see the damage they cause there, which I've circled in red. Okay, so weevil development takes 1 to 4 years depending on the temperature and the species of the stump. For example, if it's a Sitka stump or a pine stump. So in most areas like Ireland, the life cycle, which is from egg to egg, takes about 2 years. And in warmer conditions, for example, the southeast of England, it may only take 1 year, and that's called univole time. And we expect that with climate change and increasing temperatures, more areas will have a life cycle of only 1 year. In countries that are colder, like Scandinavia, it can take 4 years for the life cycle to occur. So stumps can remain suitable for weevil damage for up to 5 years. Therefore, there's a risk of damage for up to 5 years post-clear fell, but the damage risk decreases after about 2 years. So you can see there the full life cycle along the bottom. You've got the larvae first, followed by the pupae, and then lastly you've got the adult. So adults are actually attracted to clear fell sites by the smell of freshly cut stumps, and they come in from nearby forests, standing forests, or from clear cuts, so older clear cuts. The adults then lay eggs close to or into the stumps and the roots of the felled trees. Oviposition is egg laying, and that occurs from mid-May to early June, but can also last till September. And then the larvae feed under the bark above and below the ground. But it's the adults that cause the damage to the seedlings when they emerge. Here is an overview of the life cycle. So basically in red is the seasons or the periods where you get the most damage, but you can get damage at other times when the temperatures are warm enough and suitable. So you can see, I don't know if you can see with the pointer, yeah, you can see with the mouse. So you have the surrounding forest and the nearby clear fells in the corner, and that's where the pine weevils come in then to newly felled stumps from the smell that's emitted from the stumps. They lay eggs then in the stumps, and the adults emerge a year later. So this highlights the importance of felling date and planting date, because if you fell before or during the spring migration season, there's a chance that your stumps will be colonized, i.e. eggs will be laid that year with adults emerging the next year. While if you fell after the main pine weevil migration period, so after spring, later in the year, it probably isn't going to be egg laid to the following year, and then you wouldn't get adults to the year after that. Okay, so that's a brief overview of the pine weevil life cycle. So next I'm going to give you a brief introduction to the Pine Weevil IPM project that was done with conjunction with Maynooth, Teagasc, and was funded by the Department of Agriculture. And I'm actually presenting work done by a postdoc called Frauke Federwitz, which some of you may have met, but she's now working in Sweden, so I'm going to present on her behalf. So the aim of the project was to review current and potential management options for pine weevils, to look at the strengths and weaknesses of those different options, and to pinpoint where knowledge gaps exist and further research is needed. And we also wanted to refine the methods of forecasting times to help know when weevils are going to emerge, and that work was done in Maynooth. And this work was a desk study, so it was a 2-year desk study. So the project aims. So first of all, we wanted to evaluate the existing management options for pine weevils that's used both in Ireland and across Europe. That was a mixture of primary and grey literature, so literature that's published and not published, and also to take into account stakeholder experience. We wanted to evaluate novel approaches and to identify future research needs, and then disseminate this information to stakeholders. We also wanted to improve the methods for forecasting of pine weevil emergence, and Dr. Christine Griffin will talk about that later today. So first of all, what is integrated pest management? So integrated pest management is the best practice for managing pests. And what it does is it takes into account pest information about their biology and their life cycle, and it pairs that with all options available for their control, be it cultural, chemical, physical, or biological. And it aims to control the pest in the best way that has economically and environmentally with the least impact on humans, animals, and the environment. So to cover some examples of different options that's used in IPM for pine weevils. And these were all included then in the report that was put together as part of the project. So first, you want to identify your pest and to do forecasting to know if the pest is a problem, to know how you need to tackle it. So that can be done in different ways. So the report covered billet trappings, which is used in the UK, pitfall traps, and stump hacking that's used in Ireland. And there's a number of decision support systems that are available. So those are systems that help you make decisions by taking into account different factors. Quilcha has one, the UK has a hylobius management system, and Sweden also has their own one. So once you know that you've a pest and your crop is at risk, you then look at the different ways of controlling them. So first of all, we have cultural control. So there's a number of site factors that affect your pest pressure, and there's also ways of influencing the habitat and influencing the amount of damage that can occur. So that includes maybe soil. So for example, pine weevils don't like mineral soil. They prefer peat soil. You have soil scarification and mounding can be used to reduce risk of pine weevils. Your site location is important. So if it's got nearby clear cuts, that could be used to populate this new clear cut. Vegetation may have an effect. So if there's grassy vegetation there, it could be used as shelter for pine weevils. But if there's woody vegetation, it could be used as alternative food. Shelter wood can also reduce risk of pine weevil damage. Continuous cover forestry could reduce risk, and that will be talked about later by Padraig O'Tuma. Felling date is important. As I mentioned, depending on if you fell before or after the pine weevil migration period, it can influence the risk. Stump removal can have an impact, and fallow period can also have an impact, and fallow period can differ between different countries. Next, we look at how you could use physical control to reduce the damage. So two options that are available are stem coats and barrier guards. So stem coats are like a substance you spray on and apply to the seedling. So they might be wax-based or glue and sand-based. Then you have barrier guards, and they can be plastic or cardboard-based. And they're basically ways of protecting the seedling from pine weevil feeding on them when they're vulnerable. Then you have biological control with the aim of reducing populations, and that includes natural enemies like nematodes, fungus, bacteria, natural products, and Christine Griffin will talk about that in more detail later and the research that's been done on that. And then lastly, you have chemical control, so products you can use for plant protection. So there's cypermethrin, acetamiprid, and chlorothalonil, and they're different chemicals that are available for control of pine weevils. So there's a move away from cypermethrin to acetamiprid, and it is still important to have insecticides to be used for pine weevil control in Ireland because the numbers are so much higher here than places like Sweden, so it's harder to rely alone on non-chemical control options. So what is the current control strategies in Ireland? So we've reviewed all different strategies that's available. Currently, we start with stump hacking to assess the risk, whether there's risk there or not. And this will be talked about more by Colm Lyons after me. But basically, the idea is to sample at least 5 stumps on your site to remove bark from a quarter of the stump and down into the root, and to record the number of larvae and pupae of pine weevils that are there. And if the numbers are above 5, that means your site's at risk and may need an insecticide application to the seedlings. If it's less than 1, it's not considered at risk, and between 1 and 5, it requires reassessing later. And the aim of that is to predict your population level and stage. And while it's not 100% accurate, it does have good correlation with the damage risk. The next is when choosing your plant material to try and reduce your risk. So just choose strong plant material and large stem-based diameter. So there's approaches called direct planting or hot planting and green planting that can be used to plant a site directly with bare root seedlings. And the idea there is to plant directly before the weevils have a chance to get established on the site. And then lastly, if pesticides are needed, they can either be applied through dipping in the nursery or spraying on site directly to the seedlings. you don't apply any insecticides to the stumps themselves. So there's a number of challenges to controlling pine weevils, particularly in Ireland and the UK, and that's the large populations. So in other countries like Sweden, they've had great success with using non-chemical options like the physical barriers I mentioned, but in countries like this where the numbers are so high, that is more reliable on low pressure sites rather than high pressure sites. So we still require protection with insecticides because physical protections are often not enough. Migration is a challenge here, so pine weevils migrating in from nearby clear cuts. The populations are difficult to predict, that's why we use stump hacking. There is no known specialist predators for pine weevils, but we have options like nematodes, fungi and parasitoids that will be spoken about more later. There's no aggregation pheromones, so you can't trap for control, you could just trap for monitoring populations. And we need alternatives for plant protection products. So we need to reduce our reliance on chemical pesticides in line with the Sustainable Use Directive. So in the UK, there's a group called the Hylobius Industry Group, and they put together priorities that are needed for controlling pine weevils. So the priorities they listed are developing alternatives to chemicals for high Hylobius populations, to develop viable biocontrol options, to find non-neonicotinoid pesticides, to develop improved predictive population models, so to know how big the population is going to be, and to create a regularly updated guide on pine weevil management for use by all stakeholders. So 1 to 3, these points, these priorities are kind of being covered ongoing in Ireland by trials done by Coillte and also research done by industry and by universities. And number 5, we have addressed in the project by producing a guide to managing pine weevils, and there's one on everyone's seat. You may have seen them before, but this will need to be updated ongoing as chemicals become available or are lost or other control options are found to be viable. And lastly, you don't need to read this, so don't worry about the font being small. So this is the draft recommendations that are put together by the project I mentioned, Pine Weevil IPM Project. And there are 8 recommendations for what we feel it needs to be looked at moving forward in the industry for controlling pine weevils. And you each have a copy of this on your seat, along with an executive summary of the report. So the report's about 60 pages long, and it's still a draft report, but when it is finalised, it will be available online for everybody to read. So it covers all control options done in all different countries. But these are the draft recommendations we put together. So we'd actually like your opinion on them as stakeholders who would be obviously dealing with pine weevil control. So there's also a page where those 8 recommendations have a place for scoring them. And you can score them 1 to 5, 5 being very useful and 1 not very useful, and 0 if you don't have an opinion, and you can just leave them on your seat there for the end of the day. And then these recommendations will be discussed in more detail as well in the panel discussion at the end. So for example, there's ones there like, do we need a national Hylobius interest group like exists in the UK that maybe meets every year or so to talk about what are the biggest challenges? Do we want training in place for the private sector on things like stump hacking to help with assessing pine weevil damage? So things like that. So that's the brief overview to pine weevils and the project, and then all the different control options I mentioned will be discussed in more detail by different speakers throughout the day. So any questions?
What's the migration range for the weevil?
So they can, I think on average, they can fly 10 kilometres, but they can do up to 80, but that's from research. Their migration and flight ability in Ireland is not fully known. But I think Christine will talk later a bit more about understanding their emergence and things like that, the research being done on that.
Louise, at the beginning there you mentioned something about the length of the life cycle changing, maybe getting longer, is it? Is there an implication? Shorter, is it?
Yeah.
What's the implication of that?
So I suppose at the moment their life cycle in Ireland takes about 2 years with the current temperatures, and the idea then is if you fell a site and you fell it, for example, like I was saying in the risk area for migration, and they were to lay eggs that year, you would have adults the next year. But I guess as their life cycle would get shorter with warmer temperatures, you would have more pine weevils producing quicker and therefore more damage. So it would have the implication of increasing damage levels and numbers of pine weevils.
And that's an impact of climate change?
Climate change, yes.
Okay, and just I might repeat some of the questions, just if everybody couldn't hear. And basically, what was the question there was the weevil endemic to Ireland, or was it imported?
So it's native to Ireland.
Okay, we've a question here, and then we'll take one over there.
Can I just ask, is there any systematic way of recording the population outbreaks? And is there any historical data to indicate geographical or climatic influences over the past number of years?
So, Christine might be able to comment more on this than me, but certainly in Maynooth, it's part of the field trials, they would have assessed stumps and emergence over years of the trials. So all that data exists, and that is being used to try and create models to predict when weevils would emerge. Then there's things like, there's a company in the UK called Spot that's developed a trap that would go on sites, and it's meant to lure in the pests so you know when they're migrating. In terms of historic data, I don't think that there's any historic data in Ireland, is there? Other than maybe a question for Quilcha. Yeah, I don't know if Quilcha record the levels or numbers they have across sites across years. Would anyone from Quilcha be able to comment on that? No. So I don't think there's any historic data generated, but there's certainly some data from trials in Maynooth that's being used to predict pine weevil emergence.
Okay, and we have another question here.
Okay, so just to repeat the question, so the question was basically, are fungi viable control options for pine weevils, because they've been used in other countries for, and what research is being done on that. So actually there's been research done on that in Maynooth University, and that's what I did my PhD on with Maynooth. And we tested different entomopathogenic fungi, so that's insect-killing fungi, applied directly to stumps to control the larvae, so then the adults don't emerge is the idea. It didn't give as promising a results as nematodes did. Nematodes gave more promising results. The other option is not to apply it directly to the stump, but to apply it as an endophyte. So that's when you treat the seed with the fungal spores, and the idea is the plant would grow with the fungus then within the plant. And I think there's some work been done on that as well. But it is ongoing research. And Christine, she's going to talk about nematodes anyway, so that's one biocontrol option. And I think she may touch on the fungi as well. But essentially, it didn't show as promising results as nematodes.